A machine used to fill gallon-sized paint cans is regulated so that the amount of paint dispensed has a mean of 120 ounces and a standard deviation of 0.3 ounces. You randomly select 40 cans and carefully measure the contents. The sample mean of the cans is 119.9 ounces. What's the z-score of this sample mean? Alright, so I'm going to start by just drawing a normal curve. In the middle, we'll put the mean, mu, which is 120 ounces. We can show a difference between the original distribution, though, and the distribution of sample means. We know that the mu is 120 and the sigma is 0.3. But when we make a sampling distribution, we're going to have a narrower curve. And it's going to have the same mean. And we have an n of 40. So our mean of the sampling distribution is going to be the same as the original mean, which is 120. The standard deviation of that sampling distribution, though, will be sigma over square root of n, which is 0.3 over square root of 40. And so that comes out to 0.0474. So that's why it's thinner, because the standard deviation of it is so much smaller than the original standard deviation. They want the z-score of this sample mean, an average of 40 cans being 119.9. Alright, so 119.9. This is going to be 120.05 or so. And this is going to be 119.95. Yeah, so that 119.9, I guess it would be slightly to the left of that mark. We can put a star where the sample mean ends up being. Sometimes it's just a good visual display of the x bar, and that's where it lands up. They want to know the z-score of that. So this is 119.9. To get its z-score, you want to use the formula for a sampling distribution, which is x bar minus mu over sigma over square root of n. So we do 119.9 minus 120 over the original sigma over the square root of 40. Negative 2.11. And yeah, it looks like I put it in the correct place because this is a z of 0, negative 1, and negative 2. So the z-score of our sample mean, negative 2.11.